Hello and welcome to episode 2 of the Belzona podcast, your go-to podcast for all things coatings and engineering. I am Richard Bywater, Specification Development Engineer for Belzona Polymerics, and it is my absolute pleasure to welcome you to the second instalment of the Belzona podcast. In our last episode, I was joined by Belzona CEO Joel Svensson, who provided a very honest, one-of-a-kind insight into the story behind Belzona, where the company started, where the idea for polymeric coatings came from, and how the product range has developed over time. If you haven't already listened to this episode, I would definitely recommend it. That you do so. It's a great listen, and we got some really good anecdotes from it. But today, moving on. Today on the podcast, we are going to have our first insight into common industry application areas and the problems associated with it and the solutions available. A topic we're going to be covering today is high temperature coatings. And to discuss this area, I'm joined by a very special guest, a colleague of mine, Mr. Osmay Oharriz. Osmay, hello.
How you doing, Rich? Nice to be here.
I'm good. Welcome. Nice to see you.
Thanks for having me.
Good. You done anything like this before?
Not really, but it's a good thing, I think.
Yeah.
So yeah,
I feel like you're very good. You're confident. You're a good talker. So I think this format suits you down to the ground.
Pretty much, I guess. Yeah.
Good. Okay. Well, actually, another question. Have you listened to the first episode with Mr.
No,
Svensson?
I haven't actually done
You
that.
haven't?
No, I haven't had the time to do it. But
Okay. Well,
I guess now I have to do it.
you absolutely have to do it. Yeah. No. Well, we'd highly recommend that. Okay. Well, look, I'm really excited about today's topic. Obviously, you were the natural first person that came to mind when we thought let's talk about this topic with your position in Belzona. And I think what we're hoping to get out of today's episode, we want to talk about some of the problems and the strategies for managing corrosion at high temperatures, touch on where Belzona fits into this equation, and discuss what Belzona has to offer in the way of a solution. So I think the best place to start would be a bit of introduction to yourself, introduction to your role within the company, and a bit of your experience, if you're okay doing that.
Sure, definitely. So I've been with Belzona for quite a long time now. I'm a chemical engineer and specializing in like a little bit of engineering in a broad way of speaking. And when I joined Belzona back in, I think it was 2005 or 6, I started with sort of like an engineering background, trying to better understand things about coating, which, to be honest with you, I didn't really know a lot about coatings at the time.
Okay.
And then it transitioned into different industries. So I looked into wastewater treatment, and I did a little bit of different branches of different industries. And then I think that I started feeling passionate about the oil and gas industry, I think about 2 or 3 years after being with Belzona.
Yeah.
And then I found a pretty good mentor who sort of like led me in the right direction. And since then, I've been doing a lot of oil and gas, let's say, projects, mostly trying to better understand what Belzona could do for this industry, which is pretty vast, and it has a lot of potential. So at some point I became the oil and gas specialist and later transitioned into the oil and gas manager. So I think I've been pretty fortunate to have a lot of training in this industry, which I've been able to pass on to some of my colleagues. So that's been a pretty good, let's say, journey.
Great. So high temperature coatings, this is very much your day-to-day kind of bread and butter of the work that you do with Belzona.
That's right. So I do a lot of high temperature products, in applications and different things. So it's definitely a very recurrent subject.
Yeah.
Because again, it's where we see most of the damage to a lot of different equipment, and most of the asset owners are looking for ways to fix those.
Yeah.
Although they don't want anybody to know that they do have issues. Everybody knows that they do have problems.
Yeah.
So it's good to have a solution that we could offer to them.
Great. Okay. Well, look, let's get into it. So, so many process vessels or storage tanks in industries are commonly subjected to a wide variety of aggressive chemicals and elevated temperatures. What are your initial thoughts in regards to this?
Well, I will definitely agree with that statement. In many industries, most process vessels and storage tanks are mostly made out of carbon steel. And let's be honest, that's basically because it's a readily available material. It's very inexpensive when you compare it to other alloys or more exotic materials. The problem actually arises when carbon steel is exposed to several chemicals combined with elevated temperatures and pressures. And you also need to understand that sometimes it is not the actual stream to be processed, but the chemicals that you add to aid in the processing of those streams, which lead to corrosion or other different damaging effects to carbon steel. As a result of this interaction of carbon steel and its service environment, corrosive mechanisms or erosive mechanisms, or a combination of both, could actually lead to interrupted operations. And this forces the whole process to be halted or to be restarted, which, believe it or not, is the most costly problem that we see in industry. When you stop and you have to restart.
Yeah. Okay. So when you talk about elevated temperatures and pressures, what do you really mean? I mean, can we quantify these?
So this could actually change, but based on what I've seen, based on my experience, I would say that this thermal range is around, I would say 90 to 100 degrees Celsius, which is 194 to about 212 degrees Fahrenheit. And that's where I would definitely draw the line between relatively moderate temperatures and higher temperatures. So any services above 212 degrees F or 100 degrees centigrades are typically considered elevated temperature. Okay. In fact, several industries divide corrosion into low temperature corrosion and high temperature corrosion, mostly based on the presence of water. So evidently, as temperature increases, corrosion models do not include aqueous conditions. But when the temperature is pretty high, then you mostly have dry surfaces. Now, pressure plays also a big role. The higher pressures and elevated temperatures are a way more critical situation than when you have higher pressure and lower temperature, for instance. Again, based in most technical inquiries I have received, I would say that pressure levels above 1,000 psi, or 70 bars, can become problematic if combined with high temperatures. Of course, there are also many industrial processes with a lot of different services, and that's why it's a little bit hard to assign a critical number to the combination of these two parameters. But that's mostly what I've seen based on my experience.
Okay, so is this a problem only seen with carbon steel assets?
Well, predominantly, but you need to understand that some metals or some alloys, they tend to form this protective surface film, which is typically known as passivation. So take carbon steel, for instance. It could definitely form a protective sulfite layer, but when you have different chemicals in the surface, these chemicals could destroy this layer. And when that happens, they expose carbon steel to the chemical surface. Now, stainless steel, for instance, could definitely passivate, but if you have chloride ions, then these ions could definitely destroy this protective layer and induce pitting as a way of corrosion. Yeah. So it's not really only related to carbon steel. It could actually show in any other materials of construction.
So if it's known that corrosion obviously occurs and can happen, why not simply increase the thickness of the wall to add protection?
Interestingly, this is exactly what happens most of the times, and is known as corrosion allowance. So the problem is that the wall could actually be over-specified to allow for some sort of like metal loss over the years because of corrosion.
Okay.
The problems I see with this are, number one, you're adding more metal to the design, which increases the weight of the vessel significantly.
Yeah.
And some of these vessels, they could be fabricated at one location and they could just be transported into their final destination later. So you definitely have to consider the weight.
Sorry. Yeah, I was just going to say that can really add to cost as well, can't it?
Yeah, so that could definitely increase the cost of the final project because you have transportation, erection of the vessel, and those are definitely costly if you are dealing with a very, very heavy, let's say, piece of equipment. So that's one reason. The other reason is, and I think I've seen this most of the times, corrosion allowance is estimated. So it's based on expected corrosion rates. But unfortunately, the variety of service conditions that we see in industry and the different pieces of equipment that we see, you could generate corrosion rates way greater than those that you originally expected once that vessel is in service. So if you probably estimated, I don't know, 4 or 5 millimeters in addition to the original thickness for a specific corrosion rate, if it actually doubles, then you might end up with metal loss because you didn't really consider what you might expect.
Yeah.
So and it's very possible, actually, it's very recurrent that the estimated additional wall thickness is not good enough for what you expect, and that's when you need to manage that corrosion in a different way.
Okay. So this is where an asset owner needs to decide on alternative to use for corrosion control.
Definitely. So, in my view, I think all this should be considered during what we call the designing phase. So, once we have a piece of equipment that's going to be manufactured, so what are the alternatives that we have to prevent or control corrosion, right?
Yeah.
Well, there's several. I think the ones that are mostly known are an upgrade to the metallurgy that you're using, cathodic protection, and the use of different coatings just to line the inside of this vessel.
Okay.
In a nutshell, because we could be talking about each one of these categories for hours, in a nutshell, when you have a metallurgy update, you're pretty much using corrosion-resistant alloys. So think of stainless steel, for example. You can have nickel, you can have several different clads that what you're going to do is you combine them with carbon steel. So you use carbon steel for let's say the least critical sections, and then you use this corrosion resistant alloys for the most critical ones, and so the ones that are prone to corrosion. And this is how you combine relatively inexpensive material with costly materials. But this introduces another problem, because as you're using different materials with different characteristics, then you might actually end up with bimetallic corrosion if you do not design this, let's say, ensemble of different materials correctly. So that's a different subject. Now, cathodic protection, on the other hand, reduces corrosion because what it does is it makes a surface less prone to oxidation. It could be pretty complex. It could be also expensive. And then we have lining, which is another alternative and implies using a coating to isolate the surface of that vessel from the chemical surface. Now, lining could definitely protect the vessel, but it could also fail prematurely if the coating is not fit for service or if it's not applied correctly. So this is why every different alternative have definitely good points and negative, right? So it all comes down to weighing the benefits and the drawbacks and deciding on which one is the right way to go.
Yeah. And this lining option that you speak of, this is where Belzona fits into.
That's right. This is what Belzona does. So We provide low and high temperature linings for different process vessels and storage tanks at various service conditions. So many asset owners are embracing the option of lining now rather than the use of the other two that I mentioned, metallurgy update and cathodic protection. But they may actually be skeptical at times, as there is a penchant for rejecting coatings as they can fail. Well, yeah, coating could definitely fail the same way as upgraded metallurgy or cathodic protection can. It all comes down to choosing fit-for-service solutions and implementing them following our best practices. That's the bottom line.
Great. Sounds very, very easy. I'm sure there's more to it than that, though.
That's right. It's not as easy as it sounds. It all comes down to testing, training, and inspecting. And as you said, it's not really easy. So let's talk about high temperature products, right? They're intended for more critical services.
Yeah.
So many industrial sectors have developed what we know as material pre-qualification tests.
Okay.
And they have set pass or fail values for lining materials. So this qualification is obviously based on many years of experience and the recognition of both benefits and risks associated with lining materials. Belzona have discussed with several asset owners in this many different industrial sectors, and we have produced testing protocols which align with those that we find in almost every client's vessel lining testing requirements. And this includes different tests like adhesion, immersion and permeation resistance, Steamout resistance, explosive decompression, and chemical resistance, just to mention a few of them.
Okay, so from your experience then, which, if you had to pick one, would you say are the most important for clients?
Okay, so they're all definitely important because that's why we have them in the pre-qualification protocol to begin with.
Yeah.
But the most questions, and I'm going to base my answer on what we see most of the times. Most of the time we see that the most questions or technical inquiries that we get are related to chemical service.
Okay.
And the resistance of Belzona products to different chemicals and steam out.
Yeah.
And I'm very pleased, honestly, to say that we have a very comprehensive chemical resistance chart that covers various chemicals at different concentrations and temperatures up to 90 degrees C or 194 degrees Fahrenheit.
Yeah.
And this chart, what it does is it summarizes testing that we run for about 52 weeks.
Yeah.
And based on the behavior that we see, this chart classifies linings based on whether they are excellent for immersion service, or if they're good and moderate for short immersion service, or if they're poor, as in not really appropriate for any application. So this is a great tool that asset owners could definitely use, as they could see with their own eyes what we have tested, what we have seen, and how we categorize our coatings after 52 weeks of exposure.
Okay, so just to pull you back on one thing you said there, and I'll be honest, this is something I've been asked through meetings with clients. You mentioned the elevated temperatures in industry are typically seen past that 90 degrees C mark, but this chemical resistant chart only tests up to the 90 degrees C mark. Wouldn't this be a problem for an asset owner?
Definitely, and this is actually one of the questions that we get all the time, and it's
Yeah.
one of the challenges. One of the challenges that we have to deal with pretty much every single time. The bottom line, and I'm sorry that I'm too blunt as to say that, is we can't test all different chemicals at all temperatures and at all concentrations. That's physically impossible.
No.
So what we could do is we conduct what we, for lack of a better word, say fundamental chemical testing. So let's say that we take a specific chemical, let's say a chemical X, at a maximum concentration of, let's say concentration 1, and at a temperature as low as 20 degrees C. And we do the same at 90 degrees C.
Yeah.
And then we assess the behavior of this chemical X at other temperatures and concentrations based on what we saw on those fundamental chemical testing. So, and this gives us a little bit of an idea as to what we could expect if we tested at a concentration, let's say, of 20% sulfuric acid, just to give you an example.
Okay.
And we know that at 20 degrees C is excellent. And we test again at 90 degrees C, and we see that at the same concentration is still excellent, right? At 90 degrees C. That gives you a little bit of like, it gives you a strong indication that it might actually be fine if your concentration increases a little bit more, or if the temperature goes beyond 90 degrees C, you know, at a lower concentration, for example.
Yeah.
So there are different things that you could definitely consider to make more of like an educated and educated guess, or not guess, but more of like a proper estimate as to what we might actually see. Yeah. Now, sometimes we haven't tested that specific chemical in the lab, but we might actually have an application that's been in service for years and years, and then that's when your historical data comes to play a pretty important role, because you could always refer to those historical applications and use them as a reference for what you might actually expect. Sometimes we haven't tested a specific product against a specific chemical, but we could definitely extrapolate behaviors based on the chemicals that we have tested with similar chemical structure or similar attack mechanism. So there are a lot of things that we could do to make a proper selection based on historical data, based on what we have tested in the lab. And unfortunately, as I said before, there's no way that we could test everything. I will tell you this, though. Out of all the different coatings that I've seen in the market, and I don't really like talking about competitors' products, but out of all the coatings that I've seen throughout all these years, I'm very proud to say that the chart that we have is one of the most complete that I've seen all across the board. Yeah. And that's definitely something that is a positive. Whether you go to 90 degrees C or not, or you could get past that, that's definitely something that is a positive. Yeah. And it's worth mentioning it.
And it's also worth mentioning that I think on a future podcast episode, we're due to meet with a colleague of ours who works in the R&D department, who is very much a part of the testing that you spoke about, and to have colleagues who have that knowledge and ability of the products to kind of lean on for advice and guidance with the use of these linings in certain chemical situations is also a phenomenally useful tool.
I agree. Like it's not only looking at the problem from only one angle. Yeah. Like being able to talk to chemists and people that, let's say, do marketing, or engineers, or people in the field that apply the material. All this helps us get a better understanding as to where we could go. So it's not only something that is done in the lab, or that is just empirical. It's just the fact that we have different sources where we could go. And that helps in the process of selecting the material. And that's one of the things that I always tell customers. Yeah. It's not about only one person, only one individual deciding what to do. It's a combination of different, let's say, people with different backgrounds and different specialties, whatever you want to call it, that come together, and then we brainstorm, and we always try to find the best solution to the customers.
Yeah. Agreed. No, very well said. So what are other properties of our coatings which may be attractive to an asset owner? One thing I know you touched on before, for example, steamout resistance.
Yes, and this is something that I've seen quite a lot. Most process vessels are typically cleaned prior to opening for maintenance or inspection. Yeah. And this could be done by two different ways mostly. You could either use chemicals, or you could use pressurized steam. Yeah. Now, the latter is commonly referred to as steamout process. So steamout is a purging process that employs pressurized steam at temperatures traditionally closer above 200 degrees C, which is roughly 390 degrees Fahrenheit,
Yeah.
for as long as 24 hours. Although you might actually see longer than that recently.
Yeah.
I've seen several industries, they employ about 48 hours. It might change depending on where you are. So one of the things that we have done is we have tested our high temperature linings to steam at 410 degrees Fahrenheit, which is 210 degrees Celsius, for 96 hours. And this is 4 continuous days with no detrimental effect to the composition of this lining. And this definitely demonstrates the capability of our linings to resist short-term excursions to temperatures above those that we normally reference for services under immersion. And this is definitely a test that most asset owners are very, very interested in.
Yeah.
And we get questions like this all the time. One thing that we might actually do in the future is actually test at higher temperature levels than 210 degrees C, because we're seeing isolated customers or asset owners that they tend to go a little bit past 210 degrees C. So
Okay.
it might be an alternative. Again, we're always trying to get feedback from industry. So we could definitely test in the lab exactly what the customer needs. So we could go back to the customer with information that answers their questions rather than just the other way around. So additionally, customers mostly inquire about permeation testing and results. So they want to know what happens when the coating is going to be immersed. So permeation testing is very important as it assesses the ability of a lining to act as a barrier. And that's exactly what a lining is supposed to do. It's supposed to be a barrier between the chemical and the substrate. So what we do is we test our high temperature coatings in a device that everybody knows in industry as Atlas cell.
Yeah.
And sometimes we could combine an Atlas cell with another technique which is known as electrochemical impedance spectroscopy. And what we do is we use electricity conduction as an indirect measurement of permeation. So you got to understand that if you have a sample that before you put it in immersion service gives you a specific kind of electrical conductivity, and if you have it in service for, let's say, 6 months, you take it out, and then now your electrical conductivity increased, that's an indicator that there's water permeation, right?
Yeah.
So these are some of the indirect measurements that we take to better understand if there's any permeation or not. So this technique is actually fast becoming an accepted industry measure of lining performance. And is, as I said, it's combined with an Atlas cell immersion test for about 6 months. And it could be used to demonstrate whether the specific lining could provide protection or not. So out of, again, these are two of the let's say the tests that we do that I've seen most of the customers interested in. Steamout test and permeation test.
Great. So you mentioned another factor as well, which I know from experience is often overlooked but vitally important, which is training.
I wouldn't agree with you more. It is extremely vital. Like you can have the best lining in the world,
Yeah.
but if you do not apply it correctly, it's going to fail.
Yeah.
That's the bottom line.
Absolutely.
So training contractors, in my view, is the best way to have a good application. So training contractors in the implementation of lining solutions, following the best practices is paramount for the success of a coating. We have several training schools that are available pretty much at several Belson offices in the world. And training has, as I said, value to all the parties involved in the process. In fact, some asset owners, as it is right now, they mandate that contractors need to be trained and deemed competent in the application of high temperature linings before they could even go to their facilities and apply coatings, which the way I see it is it's very important to ensure that the application is successful. So we definitely make sure that all the products that we have, we have proper documentation as to how to apply it, and we go, in my view, way beyond than that, and we try to train contractors in how to implement the solutions that we have to the best of our ability, and actually their ability.
So what about inspection? So how would we inspect a high temperature lining, for example, when the asset itself is in service?
That's a great question. So as I said, and most costs associated with corrosion management comes from shutting down and starting up a lined vessel. So how can we ensure the lining does not fail prematurely and the number of inspections is actually reduced? And it's not a simple answer. It's definitely not a simple answer.
Okay.
First, you need to make sure the lining is fit for the intended purpose.
Yeah.
So that's where testing comes handy. So if we do have the testing and we have done it and we have the information, we could definitely use that to pre-qualify that material. And once we pre-qualify the material, we're able to know whether it's fit for that service or not. So that's number one. Second, you need to ensure the contractors supply the material to Belzona best recommendations. And this is where training plays a vital role, as we said. Then you need to conduct some sort of inspection right after the coating is already in service. And this is what I've seen most of the oil and gas companies do nowadays. And I'm using oil and gas as a reference because we do have a lot of products that we use for this industry. So it's a good reference for high temperature products.
Yeah.
So what they do is they monitor the wall thickness of the vessel or the tank before and after it is in service. So let's say that you take what's known as a base measurement of the wall before you line that vessel. Then you line the vessel, and after you line that vessel, you put it in service. After some time, you're going to take more wall measurements while that vessel is in service. If there's no significant difference between the readings that you took at the baseline before you line the vessel and after you line the vessel, and it's been, I don't know, a year or 2 years in service, that's a pretty good indicator that that lining is most likely still providing protection. So it's not a definite answer. It's not a quantitative measurement, but it is a qualitative measurement. So it pretty much gives you a good estimate as to what the condition of that lining is. So in a way, if you do this test, let's say after a year, and you see that everything is pretty much like before, you could estimate that you're going to let that vessel to run for another year or another 2 years and then do another measurement. And it's an indirect way to sort of like predict what might be the condition of that lining internally. And again, it's not a definite answer, as I was saying before, but it's definitely a way to help in avoiding the interruption to the process, which becomes a major problem here because it's very expensive. So again, it's not definite, but it definitely allows a lot of different asset owners to extend the service time and reduce the number of inspections. I know of several major asset owners that do this all the time. They use X-ray, they take measurements of the wall before and after, and they have a very good wall thickness profile that they could always go back to and compare and sort of like predict the condition of the lining internally. So this is one of the things that about 2 or 3 years ago, I had a meeting with some guys from Alchemeter, and we talked about how good it will be for industry to have a non-destructive device, a non-destructive inspection device that would allow measurements from the outside of the vessel reading into the vessel. So, and this is something that we talked at length, and it's they're definitely looking into, because it would be good to have this vessel in operation, take some readings from the outside, and sort of like get an estimate as to what's the condition of that wall, or eventually read the thickness of the coating inside. That would be even better, and sort of like help in the process of inspection while the vessel is in service. So there's a lot of different things that are currently being implemented in industry that they're meant to facilitate the inspection process, and again, we as Belzona, we always try to be part of that process to make sure that we have the solutions the customer needs.
Yeah. No, I think having that non-destructive option for this inspection is vitally important, and like you say, gives the asset owner the ability to not interrupt an asset in its processes to gather this data. So great. Osmay, thank you very much. This is all fantastic information. Before we tie things up, any final words that you want to summarize with?
If I would have to just like use, I don't know, 2 or 3 sentences to sort of like summarize what we've talked about today, I would say that there are many different strategies for managing corrosion at high temperatures.
Yeah.
Our goal is to provide customers with demonstrable evidence that lining, if chosen and applied correctly, could definitely be a great alternative for asset owners and provide protection to their assets. And this is, I know that it's very simple to say, but that sort of like summarizes the intention with Belzona products, is offer customers a solution that has been tested. We know how to apply it to the best of our abilities, and we provide recommendations to how to do it, and eventually be able to inspect it and provide the customer with a solution that could provide them a longer lifetime to their assets, and I would say the confidence that linings could definitely do their job.
Great. Well, look, that about wraps it up for us today. Thank you, firstly, everyone, for listening. We hope you've enjoyed today's episode. Please do not forget to like or subscribe so you do not miss out on any future Belzona content. You can find us on Apple Podcasts, Google Podcasts, Spotify, and all other major podcast platforms. For information on what we have discussed today, or for any further information on any Belzona solutions or services, please visit our website, www.belzona.com. Thank you so much for agreeing to be a part of this, Osmay. It's been an absolute pleasure having you here and hearing about your experiences.
Thank you for having me, Richard.
And I don't think it's a spoiler to say that I think we've got you agreed for more future content on the podcast series. So very much look forward to welcoming you back.
It sounds that way, yeah.
Great. So until next time, everybody, thank you and goodbye.
Thank you. Bye.